Have you ever experienced a build that worked perfectly fine on one machine, only to fail mysteriously on another? Or perhaps a new feature introduction suddenly broke an unrelated part of your application in the continuous integration pipeline. It is a frustrating puzzle that many developers and operations professionals face. The most common version mismatch errors in builds fundamentally stem from inconsistencies in the software dependencies and tools used across different environments. This means your development environment might have a slightly different version of a library or compiler than your build server, leading to unexpected failures. The core reason these mismatches occur lies in the complex web of dependencies that modern software relies upon. Applications rarely exist in a vacuum. They depend on numerous third-party libraries, frameworks, and tools. Each of these dependencies has its own versioning, and often, these dependencies have their own sub-dependencies. When the exact versions of these components are not precisely aligned across all environments, from a developer's local machine to the production server, it creates what is often referred to as dependency hell. To effectively tackle these issues, a robust strategy for managing your dependencies is essential. First, always use dependency lock files. These files, like packagelock.json for node.js or pitfall.lock for Python, record the exact versions of every dependency and sub-dependency. This ensures that every time your project is built, whether locally or on a build server, it uses precisely the same set of software components. Second, embrace containerization with tools like Docker. Containers package your application along with all its specific dependencies and configurations into a single, isolated unit. This guarantees a consistent runtime environment regardless of where the container is deployed, drastically reducing the chances of environment-related version mismatches. Third, implement semantic versioning strictly. This systematic approach to version numbering, following major, minor, and patch releases, clearly communicates the impact of changes and helps predict compatibility. Understanding and managing these version nuances is key to achieving what we call deterministic builds. A deterministic build means that given the same source code and build environment, you will always produce the exact same output. This significantly enhances build reliability and reduces the time spent debugging obscure failures. It is also a critical component of ensuring software supply chain security, as it helps prevent unexpected or malicious changes from sneaking into your builds through altered dependencies. By proactively managing dependencies with lock files, standardizing environments with containers, and adhering to semantic versioning, you establish a resilient and predictable build process. This not only saves countless hours of troubleshooting but also builds confidence in your continuous integration and continuous delivery pipelines, ultimately accelerating your development cycles and ensuring stable deployments.